lesson is about laws of exponents, and this time we are going to be multiplying and dividing, and that's why I'm calling it complex problems. So let's just review the multiplication part. I know that if I have x squared times x to the fifth, remember, we add the exponents, so that would be x to the seventh. If I go ahead, still within multiplication, if I have x to the third squared, this is our power rule, so our answer here would be x to the sixth. With division, remember, we will be subtracting, and the kind of problems that we're going to be seeing would possibly be x to the fifth over x to the third. Well, remember, that is a fraction, so we subtract our exponents, so it's x to the 5 minus 3 is 2. Just a little brief review for some of our exponent rules, and I'll be mentioning things as I am actually teaching the lesson. All right, so let's look at number 1. We have 2x to the fourth taken to the third power, and when it's written beside each other, this means times 5x to the seventh taken to the second power, or squared. Well, order of operations tells me I've got to simplify this because it's a exponent taken to a power. I've got to simplify this, and then finally, we'll put our answers together. All right, so let's start number 1. I know that 2, remember, has an exponent of 1, and this is our power rule where we're going to multiply. So this is 2 to the third power, and I have my x, and that's x to the 4 times 3, x to the 12. Well, having this in actual simplest terms would be 2 to the third power is 8, x to the 12. Here's my times sign now. All right, let's look at this guy because we have to do this first. So I am going to write 5 squared. Yes, you have to do it to the coefficient. And remember, we multiply the exponent. So 7 times 2 is 14. Again, I'm going to now 5 squared is 25. And I am just bringing down my variable of a 14. Well, remember, when we are multiplying the coefficients, we actually do multiply. So 8 times 25 is 200, but with the variable, we add our 12 plus our 14. So our final answer for this is 200 x to the 26th power. And there it is. Again, order of operations, do the first, do the second because of the exponent, and then you do multiply. All right, problem number 2. I'm looking at it, and I have 12 p to the fourth, w to the seventh, over 8 p to the third, w to the seventh. So right away, I see that I can simplify the coefficients because they have the factor 4 in common. So 8 divided by 4 is 2, and 12 divided by 4 is 3. All right, so now I see I have 3 halves so far. And when I'm writing this, I'm going to write this just like this, 3 halves. And now I'm going to write a little subtraction problem. I have p to the 4. Remember, this is a subtraction, division problem, so we subtract our -3. And then it's going to be w to the 7 minus 7. All right, looking at this problem, we know because of integers, whenever we subtract, we will be adding the opposite here. So I have 3 halves p to the 7th. And notice W is just 7 minus 7 is 0. Well, one rule that I don't believe I've mentioned that you need to remember, anytime a variable is taken to the 0 power, it's like a 1. So when I have, and it's not a 1W, it's just a 1. So looking at this problem, 3 halves P7, and I could put times 1, but I don't have to. So this can actually be our answer. And it may even be written where you have your 3, your P to the 7th is in your numerator, and your 2 is part of your denominator. Either one of these formats are okay. All right, well, let's look at the next one. I have 25x to the 9th, y to the negative 5th, over 5x to the negative 2, y to the 3rd. So right away, I look at my coefficients. My coefficients can be simplified. 5 goes into 5 once. 25 divided by 5 is 5. So now I'm just going to be writing my number. I have a 5. And I'm going to write my little subtraction problem with my exponents. So it's x. Remember, when we have a division problem, we're going to subtract the exponents. So it's x to the 9. It's a subtraction sign, and the denominator is a negative 2. And now this, we're going to do the y. So it's y to negative 5. Again, we're division problem. We're subtracting a 3. So let's go ahead and do that little subtraction. Again, we know that when we subtract, we add the opposite. So I end up with 5x to the 11th. And again, this is a subtraction sign, so I'm adding, and this is a positive 3, the opposite. Well, negative 5 plus a negative 3, we know, is a negative 8. You would say, yay, I'm done, but guess what? One of our rules of simplifying says you can never have a negative exponent in your final answer. So we're going to have our 5, we're going to have our x to the 11th. Those are both positive. But now I am going to go ahead and I have to bring the y down to the denominator. So it would be y to the 8th power. And that is in simplest form now. If this video was helpful to you today, please add a like, comment, and most importantly, subscribe for more Math with Marcia. See you again soon.